All right, so good morning, afternoon, evening, night, any of those days. Anyway, so we are going to be working on the little tiny boxes on the periodic table. And little tiny boxes on the periodic table, well, they have, excuse me, they have a lot of information in them. And the top number on the um, excuse me, the top number would be the atomic number. The atomic number, as I said before, is the how many protons, um, or it also equals the number of electrons. And the chemical symbol, that's common throughout all periodic tables for whatever language you speak. This would be C for carbon. If it was in Spanish, it would be C for carbono. Um, and usually there's also the word, the elemental name, um, or the chemical name. And but for our purposes here, we have the symbol C. Yeah, I can draw. Anyway, so the atomic mass is the other number, and this is rounded as as is the periodic table that I gave you before. You're going to need your periodic table to do this lesson about legend information, or protons, neutrons, and electrons, and how to find them. Um, Sounds like a bad book from the 1970s. Anyway, so 12. Okay, so we have 12. 12 is the atomic mass for carbon. And so we know that the atomic mass, which you can sometimes see for atomic weight, uh, but for our purposes, we're going to do atomic mass. And our atomic mass is going to equal the number of protons plus the number of neutrons. And we can rework that formula algebraically. I'm going to move this over here. Atomic mass equals protons plus neutrons. We can subtract protons on one side. And remember, whatever happens, this is an equal sign. So whatever happens on one side of the equal sign always has to happen on the other side of the equal sign. So we have to subtract p. So now we have the p's are canceled. And we now have neutrons equaling, because the p minus p is 0. So now we have atomic mass minus p. So now we can flip that formula. So neutrons equals atomic mass minus p. So, so now that gives us enough information. Remember, the atomic number tells us protons, and it also tells us the electrons. So we can go on to the next page. So the elemental symbol, let's say this is hydrogen. And the chemical symbol for hydrogen is H. The atomic mass for hydrogen is 1. So let's put that up here, atomic mass. And then we have atomic number. Make that atomic number. So the atomic number for hydrogen is 1. The number of protons is the atomic number. So that's 1. The number of electrons is the atomic number. And that's 1. Honestly, leave this column for last. Leave the number of neutrons for last. Why? Because let's do helium. Helium's an easy one. another easy one. And the chemical symbol for helium would be a capital H, lowercase e. Remember that the first letter is capitalized, the second letter is not capitalized. Because there are other elements that have not E, but there are other elements such as barium. Somebody might think it's boron and argon if they were both capitalized. So you have to make capitalized and lowercase for your chemical symbol or your elemental symbol. So your atomic mass for helium is going to be 4. Your atomic number for helium is going to be 2. The number of protons is the atomic number, so that's 2. The number of electrons is going to be the atomic number, so that's 2. So the way we figure this formula, I'm going to put it up here to begin with. So we're going to go back to our formula that we reworked. So we have neutrons equaling atomic mass minus P. Let's see if I can fit that in. Neutrons equal atomic mass minus P. I could fit it in. Good. All right. Except just an SY, the atomic mass there looks like atomic number, but yeah, that's too confusing. Sorry. All right. So if we want to find out the neutrons here, we can basically take the atomic mass for atomic mass for that would be 1. 1 minus, how many protons do I have? I have 1. So 1 minus 1 equals 0. So there are 0 neutrons in hydrogen. There's a few wonky ones which we're going to be getting into in a bit. But for the most part, the majority of hydrogen doesn't have any neutrons. So atomic mass for helium is going to be 4. Why did that do that? That was weird. Okay, I don't know why this is doing this. Sorry about this. So 4, and the number of protons minus the number of protons, that's 2. That's the atomic number. So 4 minus 2, there are 2 neutrons. So you're going to continue left to right. You're going to go through the periods. You're not going to go up and down through the groups or the families. You're going to go left to right in your periodic table. So if this is my periodic table, and I'm a very poor drawer, you should be very grateful for this masterpiece, because yeah, the rest of my drawings, they look horrible. You want to go left to right. Left to right. And you're going to end up with argon. That's going to be your last element. So argon's elemental symbol would be Ar. The atomic mass for argon is 40. The atomic, I gotta move this up so I can see. The atomic number is 18. So, yeah. Then after I'm going to leave the configuration of the protons, neutrons, and electrons for you. I'm going to do one more for lithium. Lithium would be Lithium. And the chemical symbol for lithium would be Li. And lithium would have an atomic mass of 7. And the atomic number would be 3, because remember the protons would equal the atomic number, so that would also be 3. Electrons would equal the atomic number, and that's 3 as well. And then we have the last. I'm going to let you figure out the number of neutrons. So that's how you basically fill out the sheet, figure out the number of protons, figure out the number of neutrons. It's pretty simple. Everyone has my email. If you are not part of this class, but you're watching this, you're welcome to contact me in the comments below. You all have a wonderful day, and as always, peace out.